see ya. I am Peter, and this is my first stream. So I wanted to talk about first just who I was, and then we'll talk about what we're going to do on this channel and what we're going to do on this stream. My name is Peter, and I'm a community college teacher in Portland, Oregon. I teach engineering, and then I also do some programming. So besides teaching engineering at the community college, I also write this blog, Python for Undergraduate Engineers. And I'm also the author of a book called Problem Solving with Python. You can pick that up on Amazon, or there's also an open source version that you can also see. So I started this stream because I used to play soccer every night on Tuesdays, but since soccer is no longer being played, I wanted to make sure that I felt connected in some way on these Tuesday nights. So this season, I'm hoping to do 8 weeks and hoping to do Tuesday at 8:30 to 9:30. So you can log on and check out these streams on Tuesday, 8:30 to 9:30, hopefully for the next 8 weeks. So let's talk about what we're going to do in these next 8 weeks. So we're going to work on deploying an application which is called JupyterHub. JupyterHub is a way to run Jupyter notebooks in the cloud. And a Jupyter Notebook is a way to write and run Python code, and it's often used by data scientists as well as engineers. So let's first just give an example of Jupyter, and then after that we'll see how we could see Jupyter Notebook online. So on my local computer, I've installed the Anaconda distribution of Python, and if you are an undergraduate engineer or someone who's playing with Python for the first time, I do recommend installing this Anaconda distribution of Python. I'm on a Windows 10 machine, and you can just scroll down and hit this download button, or if you're unsure, you want the 64-bit graphical installer, which is the same link that's right here. There's also an installer for Mac and Linux if you're using those platforms. If you install the Anaconda distribution of Python on your computer, then you'll have access to Jupyter Notebooks. So let me show you a Jupyter Notebook here locally, and then we'll see a Jupyter Notebook running in the cloud. So after you install the Anaconda distribution of Python, if you go to the Windows Start menu and type in Jupyter, then that's one of the applications that got installed. This will open up a quick terminal, and then once the terminal gets going, it'll open up a browser window, and we'll be able to see what Jupyter Notebook looks like in a browser window. This is taking a little bit too much time to start up. I'll show you another way to start a Jupyter Notebook. So we'll open with Chrome, that's fine. So this is an example of the regular Jupyter Notebook file browser. If we go up here and we select New and then Python 3, then we'll have a running Jupyter Notebook. So here in this Jupyter Notebook, we can write and run Python code. For instance, I could write the code, hello stream followers. And you'll see the output that running that code does. But this interface, right, it's just running through a regular web browser. So instead of the Python kernel running on your local computer, the Python kernel could be running on a cloud server instead. An example of that is this project Binder. So let's see if we can open up a Jupyter notebook up in the cloud. So if you go to mybinder.org, and then here I'll just put in one of my GitHub repositories. And it said failed to launch. There we go. I just typed the repo name wrong. So this is the same Jupyter Notebook interface, but as opposed to this one that's running on my local computer, this one is running up in the cloud. So we could click on some Python code, and that code gets run. And we've got, like, for example, this interactive Jupyter Notebook that's running in the cloud. So my Binder is great, but one of the problems is that it's stateless. So if I make any changes here, like print hello stream, it'll run that code, but next time I start this, that code won't be saved. But if we create a JupyterHub instance running in the cloud, then the server that that JupyterHub instance is running on, that will save any of the code that's running. And so by creating our own JupyterHub server, we'll have the same functionality as running local Jupyter notebooks, but they'll be running up in the cloud. So the documentation that I'm going to be following to deploy this Jupyter Notebook server can be found at this link. So professorkazarnoff.github.io /JupyterHub /ENGR114 -2019 Q4. And what we're going to go over today is just generally what the main steps are, and then we'll also talk about the setup and the tools that we need in place. And then next stream, hopefully on next Tuesday at 8:30, then we'll get started with kind of the nuts and bolts of the deployment. If you want to follow along and have access to any of the files that I create as part of this deployment, I'll be putting those files up on GitHub. So if you go to github.com /Professor Kazarnoff /stream 2020. This is the GitHub repo for all the files for this stream. And if you go here, Season 1, Episode 1, that's what we're doing right now. You can take a look at the contents, what we're going to try to accomplish. So far we've learned how to install Anaconda on Windows 10. I showed you that link. And then right now I'm showing you the GitHub repo for the stream. So we've got a local folder sitting on our desktop, and then any changes I make to that local folder, that's going to get saved. So this is the version of our documentation on GitHub, but if I go back down to my desktop, I've got this local folder here, and this local folder has the same documentation that is up on GitHub. So if I make changes here, add them, commit them, and push them up to GitHub, then all of those changes will be public, and then anyone watching the stream can go back and see them. So besides having Python locally installed on your machine, I also recommend for writing and editing code to use Visual Studio Code. Visual Studio Code is a code editor, and it's created by Microsoft. And if you go to this web address, then you'll be able to download Visual Studio Code. Visual Studio Code is also called VS Code. So if you see VS Code written anywhere, that's the same thing. But note that that's a different program than Microsoft Visual Studio. If it doesn't have the code at the end, that's a different product. Microsoft Visual Studio is a much more heavyweight, full-featured IDE, often used for .NET or C# development. Visual Studio Code is much more lightweight, and it's free. And it's great for editing text files and also editing Python files that we're going to do a little bit of over the course of this stream. So you can click this link for the download. I'm actually on a computer that I don't have administrator privileges on, so I downloaded this 64-bit user installer, and you can run that user installer even if you don't have administrative privileges on the computer that you're using. If you're unsure about 64-bit or 32-bit, you probably want 64-bit. Most modern computers are 64-bit. I've already got VS Code or Visual Studio Code installed on my machine. So I'm going to double click the icon here on the desktop, or I could also click the Windows Start menu and type Visual Studio Code in order to bring it up. So this is the Visual Studio Code window, and note that you can see the files here on the left-hand side file browser that you could see here in this local folder, that you could also see up on GitHub in this GitHub repo. So here in the documentation, I've got this local folder created, and it's linked to the remote repo on github.com. And so any changes that I make here, I can push those changes up to GitHub. So for instance, let's include like a link to where to install Anaconda here in this file. So that was this link. I'll copy that. I'll paste that into this file here in VS Code. And then let's also get the link for the stream. So the GitHub link for the stream that all the files will be saved at, that's there. And then learn how to install VS Code. Let's grab that link too. And that is here. A little trick that you can do in VS Code is that if you've got a markdown file like this, note that the file name ends in .md, that stands for markdown. You can type Control-Shift-V, and that will render the markdown file so we can see our links that we just put in. So we made some changes to our local version. Let's see how to push those up to GitHub. So I'm going to use a tool called the Anaconda prompt to do this. You could also use git bash, or you could also use a terminal if you're on Mac OS or Linux. The Anaconda prompt will install when you install the Anaconda distribution of Python on your computer. This is already installed here on this computer. So I'm going to type in Anaconda and open the Anaconda prompt. And just so it's a little easier to read, I'm going to increase the font size here. So let's make this 36 maybe. Okay. So in order to update the GitHub repo with the changes that we just made, first I'm going to cd onto the desktop, and then I'll type the dir command in Windows. This will print out the contents of the directory or see what we have on the desktop. So I can see this stream 2020 folder. I'm going to type CLS, that clears the screen on the Windows command prompt. And then I'll cd into that stream 2020 folder. Gotta spell it correctly though, stream-2020. Now if I type dir, I can see the contents of the folder just like I could in Visual Studio Code. So make sure that my file is saved here. And then I'll go back to the Anaconda prompt. And the way to link this up to GitHub is to use the following commands. So first you'd want to do git init. That will initialize the Git repository. This repository is already initialized, so I don't want to run that command. And then you want to link it up to GitHub. So then you type the command git remote add origin, and then you type in the link for your GitHub repo. And here you'd put your GitHub username, and then your GitHub repo name, and then end it with .git. So if I type git remote, it does not. Oh, it tells me here that we are running origin. So I've already got my remote hooked up here. Okay, so I want to make sure that the files in this directory are added. So I'll type the command git add and then dot. And then we want to commit them next. So we'll type git commit -m for message, and let's say edited season 1, episode 1, contents.md. So it says that we've got one changed file. That's the file that we edited in VS Code. And now we'll push those changes up to GitHub using the command git push origin master. So our push was successful. So now if we go back to github.com here, and we go into that Season 1, Episode 1 folder, and then click the contents.md, we can see the new links that we just put in here for how to install Windows, how to install Anaconda on Windows, where the GitHub repo is, and then how to install VS Code. Um, so next, what we're going to do is just make sure that our gitignore file is all set up for the rest of our stream here, because I don't want to accidentally add any files that shouldn't get shared publicly. So I want to do that quick here. So here back in VS Code, I'm going to click on the gitignore file. And if you scroll down, we've got the regular gitignore file for Python project. I just want to make sure that this .vs code directory is also ignored. And that way, any of like the specific settings for VS Code for this computer, they don't get shared up on github.com. The other thing that I want to add here is if we create any Jupyter notebooks as part of the stream, I want to make sure that the notebooks get added, but not all the other associated files. So we'll add a section here for Jupyter Notebook. And the place that I like to go to get my gitignore is gitignore.io. This is just a little website to help you get gitignore lines for different pieces of software. So we'll put in Jupyter Notebooks here, and then click Create, and then we'll copy all of these, and we'll stick all these things into our gitignore file. So let's save that gitignore file, and then we'll go back to the Anaconda prompt because we've made some changes. Let's just add, commit, and push those changes like we just did before. So I'll type git add dot just in case that file isn't part of this git repo, and then git commit -m, and then added Jupyter notebooks extra files to git ignore, and then we'll type git push origin master. And once again, if we go back to GitHub now, and we go to the repo for the stream, we should be able to look here at the gitignore file, and we can see what we just added for Jupyter notebooks. All right. So we're about halfway through the stream for today. And what we're going to do next is we're going to look at the documentation that will follow for this series. And then we'll look at the different tools and then what else we need in place in order to create our own JupyterHub deployment. And then we'll review and do a preview of what hopefully will come next Tuesday at 8:30. So let's take a look at the documentation for the deployment. And then briefly so to talk about what the main steps are, and then take a look at the tools. So generally, these are the main steps that we're going to follow in our JupyterHub deployment over the course of this stream. So first, we'll have to install PuTTY, which is a program that allows you to communicate with servers over SSH. And we're also going to use a program called PuTTYgen to create SSH keys. Next, what we'll do next week is we'll create a new Ubuntu 18.0 for server on a cloud provider, and we're actually going to use Linode. We're not going to use DigitalOcean because I've got some free Linode credits and I don't have any more DigitalOcean credits. And I'll show you during the stream where you can go to get some credits on Linode. Then after we create the server, we'll have to install JupyterHub and some Python packages on it. We'll acquire and link to a domain name. Then we'll get SSL security going. We'll also then add a couple other security features to JupyterHub. Then we'll install and configure Nginx. We'll use Nginx as a reverse proxy in front of JupyterHub. Then we'll make some further JupyterHub configurations. And I think we'll run over both GitHub authorization as well as Google authorization. So first we'll make it so that users will be able to use GitHub username and passwords to log in, and then we'll build in the functionality to allow Google usernames and passwords to log in. We might skip this part. We might not do the custom login script, but hopefully at the end we will do the call idle servers script. This little bit is helpful because it'll shut down users' servers who've logged into JupyterHub but haven't used it in quite a while. So this set of documentation is generally what we're going to follow, but we're going to do something like a little bit different here and there along the way. Right here is the documentation to JupyterHub itself, and you could also go to this Getting Started link and then go through the documentation in order to get a JupyterHub instance up and running. Okay, so to get this process going, besides the Anaconda distribution of Python installed locally, and besides VS Code installed locally, what other tools and things are we going to need to do this JupyterHub deployment? Well, one thing is that we're going to need a way to communicate with the server over SSH. If you have a Mac or you're on Linux, you can use a terminal to communicate to the server over SSH. But I'm on Windows 10 here, and so I can't just do that with the Windows command prompt. So instead, I'm going to be using this program called PuTTY. So you can download PuTTY at putty.org. It's free, open source, and pretty light weight. PuTTY's already installed on this computer. So if I click the Windows Start menu and type PuTTY, then I can open up the PuTTY application. This doesn't seem like much, but this is going to allow us to SSH into our server and communicate with our server as if we were right in front of the server typing commands on the terminal. The other thing that comes with PuTTY is this program called PuttyGen, and that's also already installed on this computer. And PuttyGen is a program that allows you to create SSH key pairs. And we're going to need an SSH key pair so that we can securely log into the server. We'll keep the private key here locally, and then we'll store the public key up on the server. And then we'll link to that key when we start up PuTTY to SSH in, and then we'll have a more secure login process to communicate with our server rather than having something like a root password. So we'll use PuttyGen to generate that SSH key. Besides a way to communicate with a server over SSH, it's also useful to be able to move over large files. And to do that, you can use an FTP client. So if you're on Mac OS or if you're on Linux, you can use something like SCP to do this on the command line. But on this Windows 10 machine, the tool that I'll use is FileZilla. FileZilla is free, but when you try to install it, at least the last time I installed it, it had like these other programs that you could like sign up for free. So if it still has that, you don't have to install any of that other stuff. Just FileZilla, the FTP client is what you'll need. And this is just useful to move big files over to the server that you don't want to type in all of the lines of the file individually manually. So on this computer, FileZilla is already installed. And I'll open it up real quick and we'll take a look at what it looks like. So this is the FileZilla window, and the way that it works is that on the left-hand side, these are the files on the local computer. For instance, if I click desktop here, we can go to stream, like we can see that contents file that we were editing earlier. And then on the right-hand side, this will have the files that are on the server. And then we'll be able to drag files over from our local computer onto the server. FileZilla also has the capacity to work with SSH keys. So the SSH keys that we create with PuttyGen, we'll use them with FileZilla so we can move over files easily. So besides those tools downloaded and installed on your computer, you're also going to need a couple other things. So if you're going to do the GitHub username and password authentication that I hope to go over, you're going to need an account on GitHub. And I also recommend having an account on GitHub to save any code or any documentation if you're following along. Saving up on GitHub is a good place to do it. I've already got an account on GitHub. That's where I'm saving the notes for the stream. But you can go to github.com/join and create your own account to save your own files and be able to use GitHub authentication. In addition, if you're going to do the Google authentication, you should also have a Google account, like a Gmail account. So if you go here and then click the create account link in Google, if you don't already have a Google account or a Gmail account, you'll need that in order to do the Google authentication. I've already got a Gmail account, so I don't need to sign up for this one. We're going to deploy our JupyterHub over the course of this series on Linode. Linode is a cloud service provider like DigitalOcean or like AWS, Amazon Web Services, or like Microsoft Azure or Google Cloud. And Linode allows you to get started pretty quickly and pretty easily. Their interface for creating servers in the cloud is a lot easier, at least for me to follow, than AWS is. I've got some free credits on Linode, and I got those free credits through a podcast that I listened to about Python. So if you go to talkpython.fm, this is the podcast made by Michael Kennedy. It's a great podcast to learn about Python, and he's also got some courses that you can sign up for. But if you go to talkpython.fm/linode, then that will allow you to get a couple of free credits on Linode. So I think I've got $20 free, and that'll be enough over the course of these weeks of streaming to create a JupyterHub server on Linode. I've created JupyterHub servers before on DigitalOcean. This will be the first time I'm doing it on Linode. I'm interested to see how it's like a little bit different, and we're going to be learning together on the stream about how to do things like the SSH keys in Linode, and also how to do the DNS routing the web addresses in Linode. So last thing that I think you'll need is a domain name. And the reason that you need a domain name is that in order to hook up SSL and use HTTPS instead of regular HTTP, which your JupyterHub users will definitely want to have in place, you want to have like a secure running instance. To use SSL, to use HTTPS, you're going to need to have a fully qualified domain name. You're going to need to have your own domain name. So I got my domain name from domains.google.com, and it didn't work. Let's try it again. But if we go to Google Domains, I guess I just spelled it wrong. I got my domain for $12 a year. Another place that you can get domains besides Google is Namecheap. And if you don't want to get a .com or I think .net, .edu, like those regular names, then you can get them pretty cheap on Namecheap. But I got mine my domain that I'll use for this JupyterHub deployment here on Google Domains. So I think that about covers um, all of the different software that I think you should have installed, and then all the different like services that I think you should be signed up for if you're going to follow along and do a JupyterHub deployment like I am. So let's go to back to our contents. So I think we'll just finish up the stream for today by doing a quick review, and then we'll preview what's going to come up next week. Next week at 8:30 Tuesday. Next week, Tuesday, 8:30 is when the next stream will be, 8:30 Pacific. So we looked at how to install Anaconda, how to create a repo on GitHub, and then how to install VS Code. Then we modified a file in VS Code and pushed those changes up. I showed you where the documentation was that we're going to follow roughly in this series, and where the GitHub repo is for any of the files that we create in this stream series. And then we also reviewed the tools that you should have installed locally, something to SSH into servers, PuTTY on Windows. You could also use a terminal on Mac or Linux, FileZilla for FTP, Visual Studio Code for editing files locally, and then Anaconda for running Python locally. And then in terms of accounts, an account on GitHub, a good place to store code, and because we'll do GitHub authorization, Google account, because we're going to try to do Google authorization, Google usernames and passwords, an account on Linode. We're going to deploy the JupyterHub server on Linode. I showed you where those free credits were, and then you'll need a domain name, fully qualified regular domain name, in order to hook up SSL onto your JupyterHub server and use HTTPS. So let's do a quick preview. What are we going to go over next week? So next week, what we're going to do is we will create SSH keys locally. And we want to make sure that we create these SSH keys before we create the server for the first time. And then after we create the SSH keys, we'll do our initial server setup. We'll create the virtual machine on Linode. We'll make sure our SSH keys are there. We'll log into the server, and we'll create a non-root sudo user on the server. So all that stuff is coming up next week. So thanks for sitting in on the stream this week. Hope you join me next week. Remember, I'm Peter, and you can read my blog at Python for Undergrad Engineers, and you can also pick up my book here on Amazon, Problem Solving with Python. I'll see you all in